Hello friends, welcome to this channel, and from today onwards we are starting with the new session or a new series on how to read electrical scheme drawings. So I will try to cover everything related to electrical scheme drawing in 2 to 3 sessions, and in the first session, which will be the basic of the reading of electrical scheme drawing, in this session I will discuss about the various symbols, the different ferrules, and the meaning of page numbers which are written on drawings, then the meaning of dotted rectangles or rectangles on the scheme drawings. So everything that are important for reading the electrical scheme drawings will be discussed in this session. So for today's session, I have already opened one of the scheme drawing, which is for this demo purpose only, and we will try to understand every aspect of electrical scheme drawing reading through this scheme demo schemes only. If you have already subscribed to this channel, or if you are watching the contents on this channel, then you must be aware that all the contents on this channel are available in both Hindi as well as English, and you may watch any content as per your requirement, and you may watch any sessions in either Hindi or English as per your convenience. So now, without wasting any further time, let us start with today's session. And as you can see on your screen, that I have already opened one of the scheme drawing, and this is the index page. And if you refer to this index page, then you can see there are some page numbers which are written on this first column. This is basically the sheet number or page number. Then the sheet title or page title, which are written over here on the right hand side. So you can see this. This is the page number, and this is your table reference or the reference title of the particular page. Then these are the revisions of drawing. So this is not much important for this session on reading the electrical scheme drawing. So now if you see, if you can or if you want to read any particular schemes, that is if you want to read for CT and VT circuit, for main 1 relay or for main 2 relay, or if you want to read the auxiliary status or auxiliary CB auxiliary circuits, then you have to just refer to the page number which is written alongside these details. So for CB manual closed and trip circuit, for example, you have to refer to page number 29, and for CB tripping coil 1 and tripping coil 2 circuits, you have to refer to page number 26 and 27 respectively. Now if you move to the next sheet, then in the next sheet you can see here that some important drawing numbers and make of the equipments are mentioned, but these are not much importance for us in order to understand the scheme drawing. So this is SLD or current transformer, capacity, voltage transformer, serial numbers and make that you can refer to on this page number. In the next page, if you see, there are the description of some of the symbols which are used in this scheme drawing. For example, this symbol is for capacitive voltage transformer. If you see here, this is for capacitive voltage transformer. Similarly, this symbol is for circuit breaker, earth switch, isolator, current transformer, surge resistor. And then there are some symbols for fuse, link, disconnecting terminals, non-disconnecting terminals, current coil, voltage coil, etc. So these symbols, if you start reading the electrical scheme drawing continuously, then over the period of time you will get familiarized with all these symbols, and then it will be easier for you to understand the electrical scheme drawing. You don't have to remember all these symbols, because once you refer the electrical drawing 2 or 3 times, then you will automatically get acquainted with all these symbols. So now for the time being, the important symbols over here are these NO NC contacts. So if you see, there are 2 types of NO contacts and 2 types of NC contacts, and NO means normally open and NC means normally closed. The type of NO contact in which there is one lines which are below this contact, this is called latched contact, latched NO contact, and this is latched NC contact. Similarly, no lines, that is unlatched, and this is also unlatched NC contact. And we will see the importance or the relevance of latched NO and latched NC contact in the scheme drawing, which we will study after this basic session. So now these are basic some symbols. So after that, you just have to see some terminal descriptions are also there. So this is your terminal description. If you see here, and these terminal descriptions, basically, if you see this XBAC or XAC, this is for AC current, and similarly this is for DC terminals. These are AC terminals, these are DC terminals. Then your T1 T2 is for the tripping circuit terminals. So like this we will discuss during the understanding of the schemes. So now just move to next sheet. On the next sheet you will see some of the SLD which are for your substation. Whichever substation you are referring to, this SLD will be present in your scheme drawing, and that you have to see as and when required, as and when you are doing any commissioning or any troubleshooting work. This SLD will be helpful. So now the first important circuit which starts is your CT circuit. So if you see the index, the CT and VT distribution, it is shown at page number 4. So just you have to go to this page, and if you see down, this is your page number, which is page number 4. So if you see here, this is page number 4, and this is for your CT and VT distribution. So now in order to understand the CT and VT distribution, you must be aware from your initial sessions which I have uploaded on the channel about how to connect the CT in case of 1.5 circuit breaker scheme for your protection and also for metering purposes. So if you see here, this is basically 1.5 breaker scheme, because just 1 minute. So just see here, these are two buses, bus 1 and bus 2, and then there are 3 circuit breakers. This is breaker 1, breaker 2 and breaker 3. This is basically one feeder which is this side and one feeder which is on this side. So 2 feeders which are controlled by 3 breakers, 1 breaker, second breaker and third breaker. That's why it is 1.5 circuit breaker scheme. Now in case of 1.5 circuit breaker scheme, if you can recall from one of my earlier sessions how to connect your CT circuits, then you must be aware that in order for your protection, that is for line protection or for transformer differential protection, you must parallel your main breaker and type main CT or type CT, and then those parallel connections of main and type CT you have to connect to your relay. Now I will discuss about this in just 1 or 2 minutes. Before that, just see this one important thing. If you see, this symbol is for current transformer. So now this is basically your circuit breaker followed by current transformer, and this current transformer, if you see here, 1, 2, 3, then 4, 5, 6. This is a 6 core current transformer. So this current transformer has 6 core, and now if you see here 3000, 2500 by 1, that means this is a multi-ratio current transformer. And if you see here, anything which is underlined or any ratio which is underlined, that means that particular ratio is selected for this particular protection purpose. That means core 6 we are using 2000 by 1 CT ratio, core 5 again 2000 by 1, core 5, core 4, core 3, and then if you see core 2, it is 3000 by 1, and core 1 3000 by 1. Another important thing, if you see this class of core 6, it is PS, that is this is core is for protection purpose. So you have to use core 6 for the connection of protection relays. Core 5 is again PS, that is protection. Core 4, if you see the class, this is 0.2, that means 0.2 accuracy class. So this is for metering purpose. Again, core 3, it is also for metering purpose. So you have to select your CT wiring. You have to do the CT wiring as per this description only. So you cannot connect this metering CT for the purpose of protection, or you cannot connect your protection CT for the metering purpose. So that's these are the things that you have to keep in mind while connecting the CTs to your protection relays. Then if you see this core 2, again PS, that is this core is for protecting purpose, and core 1 again PS is for protection purpose. Then just see here this dotted terminal P2, it is away from your feeders, because feeder is on this side. This side my feeder is here. So this is the feeder, and the CT terminal P2, which is here, this P2 is away from the period. That means when you connect this CT for formation of a star point, you have to make the star point on the P1 side of this CT. Now, this code, if you see here, this is used for 21.1. 21 is for distance protection and 0.1 is basically for your main one. So this code is for distance protection main one relay. And since it is used for distance protection main one, so that you have to make one parallel connection with tie CT also. So this is the main CT, and now if you see here, one line is emanating, and now it is connected to the another terminal of your tie CT. So if you see the description of the tie CT, it is again 6-core CT with 4 protection cores. This is protection core, metering, and then protection cores with the CT ratio at 3000, 2500 by 1, and you have to connect the same CT ratio for both main and tie CT. So if that core 6, which is used for distance protection, and you are connecting with core 6 of tie CT, so again here you have to select 2000 by 1. Now this 2000 by 1 and this 2000 by 1, it is parallel. This will come to or this will go to main one protection. The number which is written over here in this rectangle, that is 08, this refers to your page number. So if you want to see the further connections of current transformer to this main one relay, then you have to refer to page number 8, that we will say later on. Now the core 5, it is again used for main 2 protection, so this must be parallel with tie CT. So one line is emanating from here and it must be connected with your tie CT. So if you see here, this is connected with your tie CT core 5. Similarly, you will have the metering core. So this metering core, it is again main and tie CT will be parallel and it is connected to your DCO. I will explain to you these different circuits, that is main 1, main 2 and DCO circuit later on during our second or third session. Now this core, that is core 1 and core 2, it is basically used for bus bar protection main 1 and main 2. So if you recall from the bus bar session that in the case of 1.5 breaker scheme, your bus bar main 1 or bus bar for bus 1, it will protect all the main breakers connected to that bus. Similarly for bus 2, all the main breakers connected to that bus. So you don't have to connect or you don't have to take the current signals of the tie CT. So that's why in case of bus bar, only main bay currents are available. So core 2 and core 1, that is 2 bus bar protection CT. Now moving to the next page, or before that, you can see that tie CT, we have already used 3 cores, 1 and 2, that is for main 1 and main 2 distance protection, core 3 for metering. Remaining 3 cores you can use for the other side feeder. So if you are having second feeder on this side, then these 3 cores will be used in parallel with the main base CT of other side feeder. So now moving to the next page. So this page will show you the tripping matrix, which is not important for at present, but we will discuss about this tripping matrix later on. Now the most important thing, which is your DC distribution circuit. So if you see here DC distribution, it is very important to understand that in case of any circuit from here on, there will be some dotted rectangles and some circuits will be present inside those dotted rectangles. So if you see the first over here, this is a small rectangle in which there is resistant DC supply 1. That refers to your DC supply panel, basically your battery charger and DC DB. So all those connections will be there only. Then this rectangle in which there are multiple fuses which are connected, and this refers to your panel number 712RA. So this may be some panel, and in this panel there are these 4 circuits which are available: main 1 protection, distance protection, then bus bar, then CB triple coil 1 and 86.1 relay circuit. But before that, if you see this DC supply 1, so the DC supply 1 which is coming from DC DB directly to your relay panel, that is panel number 712RA. So the ferrules which are used for your DC supply are basically J and K. So J ferrule, it is basically used for the main DC supply or main DC source which comes directly from your DC DB to the relay panel. So this main DC supply which is coming from the main DC DB source to relay panel, it is designated as J102 and J101. Now another important thing, when you see here this J101 and J102, When it starts with 1, that means it shows your DC source 1. Similarly, for source 2, it will start with 201 and 202. So if you see here, this 201 and 202, this is basically for your DC source 2. 01 and 02 is basically for positive and negative terminals. Now when this DC comes through after this fuse to the different circuit, it is going. So the ferrules which are used now starts with K. K is basically for your controlling circuits. So if you are controlling the main one, distance protection or bus bar circuit or tripping coil or master trip relay, then those ferrules will start with K. So this K101, 701, 501, these are basically for source 1. Similarly, for source 2, it will start from even numbers like 201, 601, 801, like that. So K201, 801, 601. For breaker, the source 1 is generally designated as K1, K2, and for source 2, it is designated as your K51, 52. Now if you move to next, so again there is a one small rectangle, dotted rectangle. In those rectangle there are some circuits, and this rectangle now designates your next panel. So this, if you see, this is 712 RB, and the main DC supply which is coming from DC source 1. So this is the main DC supply which is coming, and now this DC supply is extended to new panel. So since this is the main DC supply only which is being extended to new panel, so this parallel again starts with J. That's why this is J103, 104, and the controlling circuits of various relays inside the second panel, it will be with your K ferrule, that is your K something like that for this, and the main DC which is coming here till this point is all your J. So now you can see that these are basically DC distributions, and then important thing over here is this DCCO. This DCCO means DC changeover relay, and if you see there is one circle. Inside this circle OP is written, that is this is your operating coil. These are the two terminals of the coil, A1 and A2. All the electrical scheme drawings are generally made with the assumption that your lines or your feeders are in shutdown condition. So all the drawings are with de-energized conditions only. So all the contactors are with de-energized conditions. All the auxiliary relays are with reset conditions. So if you see here, this is one of your changeover relay or one of the auxiliary relay which have four NO-NC contacts, two NO contacts and two NC contacts. Then one small line here, that means this is a latched contact. So whenever your this relay operates, this NO contact will become NC, and this NC will become NO. When this relay is in reset condition, then these two contacts will be NO and these contacts will be NC. So this is the basics of your DC distribution. Now moving on to next page. So the next page, if you see here, this page is basically for your AC circuit. And in the AC circuit, again, there is one small dotted rectangle that is for your AC supply, which is coming from ACDB. Then some panels, that is 712RA. The AC supply basically is used only for the heating and lighting purposes. And if you see the AC ferrule, it starts with H. So H1, H2 is basically your AC supply. And then it will go through these fuses to CFL and for heater circuit like that. So this is again the next panel, or for adjacent panel also, that is the distribution of AC circuits. Now this is the main circuit which starts, and this is the circuit of your main one distance protection relay. I will discuss about this circuit in the next session, but before going to the next session, there are some important thing, that is the ferrules. So if you see the ferrule for the current transformer or CT ferrule, it starts with A for the main protection. So that is A113 or A133, A153. This A ferrule, which generally shows the description of main protection, the current transformer circuit for main protection. Similarly, E is for your voltage circuit. So E513, E135 or E155, anything that is for your voltage coils. A is for main protection, CT connection. Then B is for backup. C and D is for metering purposes. So anywhere if you see these current channels or current ferrules, then you must be able to identify this by seeing only the ferrules. So we will keep only up to this point in this session. Basically we have discussed about the different types of Fair rules, the designations of fair rules for AC, DC, CT, PT, everything we have covered in this session. If you like the content, then you may share this video with your friends so that more and more people get aware about this concept and they may apply this concept at their organizations also. We will meet again in the next session with the continuation of this series. Till then, thank you and goodbye.